Ayun. So, in this video naman, pag-usapan natin yung mga timers and counters. So, yeah. So, ang topic natin for the week is interrupts. Pero medyo mahirap mag-discuss ng interrupts without discussing yung mga sources ng interrupts. So, the first one that we will be discussing is yung counters and timers. And how do we configure yung ating counters and timers and ano usually yung parang parts niya ng counter or timer sa microcontroller. So, counters, as the name suggests, counts the number of clock cycles that have elapsed. So, pag alam mo kung ilang beses, wala, I think meron tayong, ano yun? Meron ba tayong example nung 158 na nagbi-blink-blink yung LED, tapos bibilangin mo ilang beses siya nagbi-blink per second para makuha yung frequency niya. Then, pwede rin tayong pag nag-check tayo ng pulse, bibilangin mo. And then, makukuha mo kung ilang beats per minute. So, yan, di ba dapat 100 BPM or something. So, basically by counting something and alam mo yung duration ng isang something na yun, pwede mo makuha kung gaano katagal siya nag-count. So, for example, anong tsura ng counter na digital na circuit? So, ito yung, basically, para siyang chain ng toggle flip-flops. So, ito yun. Bakit toggle flip-flops? So, ito parang, kung yung input natin is high and low, high and low, high and low, isang edge lang mag-toggle yung flip-flop natin. In this case, I think it's a negative edge. So, ayan, yung negative edge natin dito, siya yung nag-trigger nung pag-high nung Q0. And then yung negative edge ni Q0 dito, siya yung nag-trigger nung negative edge ni Q1. And then si Q1, yung negative edge niya yung nag-trigger nung negative edge ni Q2. So what you'll notice here is that for every clock cycle nung input, meron tayong isang state nung output. What do I mean by that? So isang high-low dito, isang high kay Q2, isang low-high dito, isang isang state kay Q3. So, essentially, nabibilang natin kung ilang clock cycles yung nag-elapse doon sa previous na input. So, si Q0, binibilang niya kung ilan yung clock cycles ng input. Si Q1, kinakount niya yun kung ilang clock cycles na si Q1 ay si Q0. And this actually would represent yung ating bits ng ating timer. So, let's check over here. Dito sa ating logic digital circuit sa Logic. Yeah, I'll send a copy of this din naman. Pagka nilaro natin yung clock, so yung napansin yung prescaler na yan. So, pag nagkaroon tayo ng clock, magsa-start yung ating timer value at 1. After another clock cycle, magiging 0010, which is 2. After another cycle, 0011, so that's 3. So, nagbibilang na tayo sa pang-clock cycle. So, meron tayo 4. Isa pa. Meron tayo 5, 6, 7, 8. And then, ayun, pag dumating tayo dun sa maximum value, mag-on to, magkakaroon ng timer interrupt. So, yun, itong basically sa gitna yung ating timer. And then, ayun, pagka alam natin kung ilan yung clock ticks natin per na nag-elapse or yung kinout natin and alam natin yung clock frequency, alam natin kung gaano katagal na yung time na nag-elapse. So, for example, meron tayong 8-bit na counter and a 60 MHz na clock. That means 2 to the 8 minus 1. So, yun yung maximum number of clock ticks natin, 155, divided by 60 times 10 to the 6. That's 4.25 microseconds. So, ito, meron tayong 4-bit na clock, counter dito. And depende kung gaano kabilis ako mag-click, ganun katagal yung time bago siya mapuno. So, ayan. Okay. And then, ayan. So, another question. How many bits yung kailangan natin for 5 milliseconds with a 60 megahertz clock? So, ayan, 5 milliseconds, parang manipulate mo lang yung equation. Makuha mo na 5 milliseconds times 60 times 10 to the 6. Kailangan natin ng 300,000 na ticks. So, 300,000 can represent that using 19 bits. So, medyo madami ata yun. 19 bits. For example, yung PIC32, meron na siyang 16-bit na timers. I think STM32, tig 16-bit din sila na timers. So, ano yung pwede natin gawin? So, yun yung tinatawag nating, or ano yung pwede natin gamitin? So, yun yung tinatawag natin na prescaler, na dinadilute yung input clock signal natin. So, let's set yung prescaler niya to 8. 3, 4, 5, 6, 7, 8. So, after 8 clock cycles, doon pa lang mag-on si 8. So, yan, yun pala nag-on si 8. So, magkiklik pa ako ng 8 more times bago mag-count yung ating timer. And then another 8 more times, 1, 2, 3, 4, 5, 6, 7, 8. Hindi pa ba ako naka-8? Ayun. And so, every time na maka-8 na clocks dito sa input, tsaka lang nag-update yung ating mga counters. So so parang binabagalan natin yung ating timer in this case. So, yun, pag yung value natin is into 1, yung ating value nagtatagal yung output every input edges. So, effectively, yung input natin na clock frequency is nadi-divide by n. And so kung ito for toggle flip-flops, we have a 4-bit na timer. Then, timer value register, yung current counter value na natin. And then, period register determines yung timer rollover. And then, pag nag-equal yung rollover at saka timer value, interrupt signal is set. So, ano itong period register? So, ito yung determine kung gaano natin gusto katagal gamitin yung timer. So, hindi naman pwedeng palaging punuin yung 4 bits. So, for example, pwede natin iset yung period register natin to 8. So, after maging 8 lang nung timer value, magro-roll over na yung ating, or mag-generate na yung ating interrupt. So, after 8, after 8 clock cycles, timer interrupt is asserted. So, and after din mag-equal ng 1000, babalik to 0 yung timer value natin. So, given yung ating period register and yung prescaler, we have a updated equation ng ating timer period or in duration ng ating n-bit na timer. So, di ba, clock ticks over clock frequency, pero yung clock ticks natin, limited siya by our period register. And then yung ating yung clock frequency natin is divided by the prescaler value. So, yung total timer period natin is yung period times prescaler over frequency ng ating clock. Tapos, depende din sa ginagamit natin na microcontroller, one cycle is usually added to account for delay ng rollover. So, depende rin sa ating device kung ilang cycle siya. Pero usually, one cycle for the rollover. So, ano yung rollover delay? So, di ba mag-equal muna sila? Yeah. So, mag-equal muna sila. So, kailangan natin ng isa pang clock cycle para mag-reset ang lahat and makapag-count ulit. So, ayun. So, yun yung +1 dito sa rollover delay. So, okay. So, technically, if meron tayong iba't ibang prescaler values, pwede rin tayong magkaroon ng iba't ibang period register values and mag-result doon sa same na duration. For example, if meron akong 256 to 1 na prescaler and a 4-bit timer, kailangan ko ng pagka yung buong 4 bits ginamit ko, makukuha ko is 4.096 seconds. Pag 1:1 na prescaler pero 12 bits yung timer, ayun din, makakuha din akong 4.096 seconds. However, yung question dito, yung lower prescaler natin has a higher precision. So, let's say gusto natin ng delay na saktong 1 second, because of yung period register natin dito, may 256/1K tayo. Yung kailangan natin or yung makukuha lang natin is 1.024 with a period register of 3. Pag meron tayong 1:1 na prescaler, kaya natin siyang iset na yung prescaler is 1,000. I mean, yung period register is 1,000. And saktong 1 second yung makukuha natin na delay. So, ayun. So, parang may trade-off, no? So, pag mas mataas yung prescaler, lumalaki yung time na pwede nating makuha. Pero, yung ating precision or yung differences or gaano kasakto yung ating timer values is nag-affect. So, in summary, yun nga, ang counters natin, kinakount lang natin yung number of clock cycles. And dahil alam natin yung frequency ng ating clock, alam natin kung gaano katagal na siyang nagka-count. And then, meron tayong ginagamit na tools to extend yung timing capabilities ng counters natin. Kasi, or yung timers natin. So, mahirap naman if fix lang lagi parati yung counter natin, hindi natin ma-adjust yung delay. So, yung prescaler allows us to extend yung range ng timer at the cost of precision. And then, yung ating period register naman, with a comparator, allows yung flexible setting ng timer duration. So, by varying yung period register, yung timer natin can vary its period or yung kanyang delay. And yung prescaler naman is, ayun, namumultiply naman natin yung delay if kailangan natin yung malaking delay with a very fast na clock. So, yun lang for this video.